So here's an example dealing with measures of relative standing. Just a reminder, measures of relative standing that we're going to discuss in this section include percentiles, quartiles, and z-scores. Measures of relative standing talk about position of a value in a data set relative to other values in that data set. So the first example we're going to talk about discusses z-scores. A z-score, or a standardized score, tells us how many standard deviations a data value is above or below the mean of the data set. So example 1. In Tokyo, the average 2-year-old boy weighs 25.6 pounds with a standard deviation of 1.2 pounds. And the average 2-year-old girl weighs 24.3 pounds with a standard deviation of 1.1 pounds. So the first question, Cho is a 2-year-old girl who weighs 27.4 pounds. Convert her weight to a standardized score, or we also call that a z-score. So if we take her weight, which is 27.4 pounds, there is a formula to convert this weight to what we call a standardized score. If we convert her weight to a standardized score, we can use that z-score, or that standardized score, to compare it to other weights. So the formula here, z is equal to x minus mu. So this tells us how far the data value, or the girl's weight, is above or below the mean. Then you take that difference and you divide by the standard deviation. And that tells us how many standard deviations her weight is above or below the mean. Well, she weighs 27.4 pounds, and the average weight for a 2-year-old girl is 24.3 pounds. So since her weight is higher than the average weight, that tells you that the z-score is going to be positive before you even calculate anything, because it's above the mean. So her weight, 27.4, minus the average weight of 2-year-old girls is 24.3. You take that difference and you divide by the standard deviation, which is 1.1. So you end up with a z-score of 2.818181 repeating. So z-scores are typically rounded to 2 decimal places. So her weight as a z-score is 2.81. What this tells us is that her weight is 2.81 standard deviations above the mean. So second question. Echo is a 2-year-old boy who weighs 26.94 pounds. Convert his weight to a standardized score, or a z-score. Well, we're using the same formula to convert the weight to a z-score. So the formula is here. His weight minus the average weight of a 2-year-old boy. We divide that by the standard deviation. So his weight was 26.94 pounds minus the average weight of a 2-year-old boy was 25.6 pounds, which once again, he weighs above the average. So that tells you the z-score is going to be positive. If he would have weighed, let's say, 23 pounds, then the z-score would have been negative because his weight is below the average. Then you take this difference here and divide by the standard deviation, 1.2. You end up with 1.11666 repeating. Once again, we typically round to 2 decimal places. So the z-score that corresponds to his weight is 1.12. This means that his weight is 1.12 standard deviations above the mean. Now that we found the standard deviation, the z-scores for both of the children, who weighs more relatively? Well, we can see that the boy weighs 26.94 pounds and the girl weighs 27.3 0.4 pounds. We're not actually asking who weighs more. We're asking who weighs more relative to their mean. So if we actually compare the two z-scores, 2.81 is more standard deviations above the mean. It's more extreme than the 1.12. So since this 2.81 is more extreme, or it's more standard deviations above the mean, that says that Cho's weight is more extreme relative to the average weight of a girl. So Cho weighs more relatively. Next question. Is Cho's weight considered significantly high for a 2-year-old girl? Well, to determine that, you look at the z-score. If the z-score is within 2 standard deviations, so if the z-score is between -2 and +2, we would say that weight is not significant. If the z-score is 2 or larger, we would say it's significantly high. And if the z-score is -2 or smaller, we would say that weight is considered significantly low. Cho's weight converted to a z-score is 2.81. So what that says is her weight is 2.81 standard deviations above the weight of an average 2-year-old girl. Since 2.81 is greater than 2, it's more than 2 standard deviations above the mean, we would say that her weight is significantly high. The 2.81 says that her weight is more extreme. It's more than 2 standard deviations, so it is significantly high. Is Echo's weight considered significantly high for a 2-year-old boy? Well, if you recall from the previous example, when we converted his weight to a z-score, we got 1.12. Well, 1.12 is within 2 standard deviations. In other words, it's between -2 and 2. So we would say his weight is not significant for a 2-year-old boy. Basically what that's saying is that if it's more than 2 standard deviations from the mean, it's very, very far away from the average weight of a 2-year-old boy. So we would say if it's more than 2 standard deviations, so greater than 2 or less than -2, it would be significantly high or significantly low. If it's within 2 standard deviations, between -2 and +2, we would say it's not significant, meaning it's not very far away from the average.